Hi, Year 10. So this is your motion and measurements test we're going to have a look at. The multiple choice section, question 1, average speed is just total distance divided by total time. But we need to make sure that the distance was in meters and the time was in seconds. So 2.4 kilometers is 2,400 meters. 12 minutes is 12 lots of 60 seconds is 720 seconds. Plug that in. You can see that you get 3.3 meters per second. In question 2, the graph shows how the speed of a car changes, which row gives the greatest acceleration and the greatest deceleration. Acceleration is where it's speeding up, so we're going to look for the steepest gradient because the gradient is the acceleration, so that's obviously going to be this section. The deceleration is where the gradient is negative, but again, the greatest value is where the gradient is steepest negative. So we're going to pick this section because it's clearly steeper than it was here. So then we have to do the change in y over the change in x to find the gradient, the rise over the run. So for the greatest acceleration, it changed by 20 in a time of 15 seconds. And then for deceleration, it was minus 15 over 5 seconds. So the deceleration was minus 3 meters per second. So to be clear, the acceleration value would be minus 3 to show it slowing down. If you use the word deceleration, you already have the negative involved in the fact that it's deceleration rather than acceleration. So the value of the slowing down is 3. So you choose D there. In question 3, a student measures the volume of a small, so it will fit in a measuring cylinder, irregularly shaped stone. So we can't do a sphere volume. So we need to find out how much water it will displace by dropping it into the measuring cylinder. And if we know the original level and the final level, we therefore know that the amount of water that has been displaced is the volume of the stone. So we only need the measuring cylinder with water for that one. For question 4, the motion of an object is represented by a speed time graph. Which quantity is equal to the area? Well, area is the height times the base is a speed multiplied by a time. Speed times time is distance. So you just need to either memorize this particular type of question, or you need to remember the equation and know that if you've got a speed multiplied by a time, you have a distance. In question 5, sorry, I didn't quite fit. You've got a student wanting to measure the volume of 40 centimetres cubed of water. She has 2 measuring cylinders, a larger one that can hold 100 centimetres cubed and a smaller one that can hold 50 centimetres cubed. The water forms a meniscus where it touches the glass. So I've drawn that a bit bigger over here. What that means is the walls of the container provide some surface tension. They pull that water up at the edges. So it's not actually as high as the top point. Its real value is the bottom because that's the level of the water. So you read from the bottom. To get an accurate result, we want the value to be as close to the truest value as possible. So we need to be able to measure to a smaller level of precision. So we know that with a 50 milliliter cylinder, we're going to have smaller gaps between each marking. So we can be more sure to a more precise value of the value of the water. Whereas if it's somewhere between the 10 and the 20 and the 20 and the 30, for example, we have to kind of either round to the nearest one we see or judge if it's at the halfway point. That's much less accurate, so we would choose the smaller one. In question 7, the diagram shows a speed time graph. Which description of the object's motion is correct? So we can see that we have a curve, so we're going to want to know what the gradient represents. It's the change in speed, the y, divided by the change in time, the x. So the slope, the gradient, gives us the acceleration. So at time 0, the gradient is pretty steep, but as time goes on, let me see if I can make it a bit more obvious. As time goes on, the steepness is getting smaller, okay? So the gradient decreases. It starts steep, it decreases as you follow. Okay, so I'm following this section. So the gradient decreases, therefore the acceleration also decreases. In question 7, a train is on a straight track. The graph shows how quantity y varies with time. Which statements can be true? So stationary means not moving. So if we were to place in number 1 the distance on this graph, the distance would be the same at all points in time. You'd read the same distance at any point in time. That is true. That would be stationary if the distance wasn't changing. If the train was moving but y represented the distance, that obviously wouldn't then make sense because the distance hadn't changed, so the train couldn't be moving. So you can't be both moving and have distance on this axis. In 3, the train is stationary and y represents the speed of the train. Well, this would be a non-zero value, which would mean that if this was speed, this would be like, I don't know, 5 meters per second. So obviously, if it's moving at 5 meters per second, it cannot be stationary. 3 is wrong. If the train was moving, again, let's say it was 5 meters per second, then yeah, it could be moving, and it could be moving at a steady speed, so that is true. So 1 and 4 are true. A student in question 8 measures the average speed, which is distance over time. Notice how I annotate this to myself. So then I know that I need to know these 2 things, and I look for the one that includes distance and time. And it really is as simple as that for that one. In question 9, this is a bit trickier. An object reaches terminal velocity after being dropped and falling through air. Which graph shows how its speed varies with time? So we know that the gradient of a speed-time graph is acceleration. We know that initially when it's dropped, the only force that acts is weight, and so it accelerates due to gravity. But as it falls through the air and the air resistance increases, the overall force on the object decreases until it's balanced. When air resistance equals weight, we don't have any acceleration because we don't have any force. So we know that by the end we have to have a constant speed. So we know we do want the flat line at the end, but we know that if the resultant force gets smaller, then we know that the acceleration also gets smaller. And the gradient of the graph is the acceleration. So we need the gradient to get smaller in order for that to happen. In question 10, the speed-time graph shows the motion of an object. How far? Far means distance. Distance is area under a speed-time graph. Does the object travel at constant speed? I've highlighted the only part of the graph where the object is at a constant value of speed, so I only want the area of this section. So I've got 10 multiplied by 5. In question 11, which statement about a falling object is correct? So C is correct. The weight of the object is constant. That's just the force felt by an object because of its mass, and it's in a gravitational field, so that's the only one where that's constant. But the force of the air resistance is increasing. That's true because if you fall and you accelerate, you start to fall through more air per second, so the air is going to hit with more force. Okay, more air particles hitting means more force. So we know we can get rid of D and A because weight never changes. But we know that if we have acceleration, we have a resultant force. So we cannot have the forces balancing out because that means that we don't have any overall force. We wouldn't have any acceleration. In 12, a light ball is held at rest at the top of a tall cliff, released and falls through the air. Which road describes the behaviour of the ball as it descends? Descends just means falls. Okay, the starting acceleration of the ball, well, initially the only force that acts is the weight because they haven't fallen through any air yet. Okay, at the moment it's released, it hasn't hit anything yet. So the only force that causes acceleration is gravity. When it reaches terminal velocity, we know that the weight up equals the weight down equals the air resistance up. The resultant force is 0, so the acceleration is 0. Again, we've got a how far. Far means distance. Distance is found by the area of a speed-time graph because distance is speed multiplied by time. So we are going to do a half times base times height. We're trying to find this area. A half times 5 times 10 gets me 25 metres. In question 14, the diagram shows speed-time graphs for 4 different bodies moving for 4 seconds. Which body travelled the least distance? So again, distance is the area under the speed-time graph. So you'll see I've calculated the area of each one. So sometimes I've split it into 2 shapes and then added it up, but you can see that the smallest distance is B, so you can pause that and have a little look there, but that's pretty straightforward. In question 15, a car starts from rest. You've got the speedometer value every 10 seconds. So you can see that for the first 30 seconds, the increase in speed every 10 seconds is the same. It goes up by 4. So we have the same acceleration throughout this whole section because every 10 seconds we go up by the same speed. So that's non-zero. After 30 seconds, though, the value of the speed stays the same, so there is no acceleration. We're moving at constant speed. So this gives us answer D. Oh, sorry, I think there's a fly floating around. Okay, in question 16, a skydiver jumps from an aeroplane and falls towards the earth. Which statement is correct when the skydiver has reached terminal velocity? You just need to remember that the phrase terminal velocity means constant speed. That one's just to remember. In 17, it asks you what you can calculate from the gradient and the area of a speed-time graph. The gradient is the change in y divided by the change in x. So speed divided by time. Change in speed over change in time gets us an acceleration. The area is a half times base times height. That's a speed multiplied by a time. That gets us distance. That gives us A. In 18, the graph shows how the speed of a car varies with the time. So we can see that as time goes on, the speed, how fast the car is going, is clearly increasing. So the distance travelled per second is increasing. In the first second, they only travel about 1.5. And then in the second they travel nearly 2. And so it increases, the speed increases as time goes on. So if the speed increases in the same length of time, so every second, the distance that you travel will increase. So you can see that in the first section, I only travelled a very small distance. In the second, I travelled slightly larger. In the third, I travelled even larger. And in the fourth, I travelled even larger. My distance increase got bigger as time went up. Okay. We also know that we can find the total distance from a speed-time graph by doing the area under the graph, which we had from this question. So the area is a half times base times height. So a half times 4 times 6 is 12 metres. So that means I know that I'm picking A and not C. In number 19, we've seen this question before. I hope you could remember it. The length of a train is the distance, right? It's a length in meters. It's a distance. That's equal to speed multiplied by time. So distance is speed multiplied by time. We take the speed of the train. We multiply by the time taken. 80 metres worth of train has to have travelled past that person. In 20, which graph represents an object moving at constant speed? So speed is the gradient of a distance time graph. Distance divided by time is speed. Rise over run is speed. If it's a constant speed, I need a constant gradient, so I can get rid of B and C. A also has a constant gradient, but the gradient is 0, so it has 0 speed, so that cannot be right. So it has to be D. In 21, it was just checking you could read a ruler. You could judge that each interval was worth 2. It started at 2. It finished halfway between the 8 and the 10. That's a 9. The difference between those two is 7. In 22, 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored, which means that they all accelerate because of gravity only. Which ball has the smallest average speed? So the one that travels the smallest distance will accelerate for the least amount of time. If it accelerates for the least amount of time, its final velocity will be smallest, okay? This one will reach the ground faster, even faster, fastest. So the average speed, given that they all start from 0, is going to be smallest in the one that has accelerated the least. In 23, a cyclist rides 300 metres up a slope, then back down. The total distance travelled is 600 metres. The total time is the 50 plus the 25. Average speed is distance divided by time. 600 divided by 75 gets you 8. In 24, you just had to remember the piece of equipment to measure mass. That was a balance. A weight is Newton metre, don't mix those up. 25 was the hardest question on the paper for sure. So a ball is thrown vertically upwards through the air. Air resistance acts. Which graph shows how its speed varies with time? Really challenging. If you got this wrong, absolutely not a problem. So visualize what's happening. It's thrown up, it comes back down. So it's fastest the moment it's released, and then it's slowing down as it gets to the top, and then it speeds back up again. Now let's think about the way up. As the ball slows down, because it's slowing down on the way up, it will hit less air particles per second. So the air resistance will be dropping, will be getting lower. The resultant force will decrease. This means that the deceleration, so the acceleration but slowing down, will also decrease. A speed time graph, the gradient represents acceleration. So if the acceleration decreases, the gradient gets less steep. So you can see that we have to curve down, okay? So we can already get rid of A and B, okay? Because this gets more steep, this is constant. So we've got less steep, okay? When speed is 0, that's when it's at the top, okay? So this is where it's traveling up, but it is slowing down to the top. On the way back down, the weight acts down, the air resistance now acts up. Initially, it's travelling really slowly, so the air resistance is small. So the force down is largest, the acceleration is largest. So the gradient of the graph, which is acceleration, has to be steep. But as it speeds up, the air resistance increases. It hits more air particles per second. So what that means is the air resistance starts to match the weight. So the overall force gets smaller, which means that the acceleration gets smaller, which means that the gradient also gets smaller. It also gets less steep. So that's how we get to D. So there are your multiple choices.